Gomez and President of Gwalior Zone Research Foundation of India. I would like to welcome you all in today's event. I feel privileged to extend my warm welcome on the day 2 of Faculty Development Program Statistical Tools using SPSS, organized by RFI and Rama University, sponsored by World Federation, HERF, ARGA. Thanks to all of you. The Research Foundation of India is strictly working for the social upliftment and higher education, quality and Indian research promotion in the form of events like international, national conferences, seminars, workshops, symposium, and other activities. I would like to welcome Dr. Saurabh Jain sir, Chairman and CEO of RFI, Ashok Kumar Gupta sir, Chief Managing Director, Reshu Jain ma'am, President, Dr. Ajay Jain sir, National Coordinator RFI. I would like to welcome Dr. Priyanka Chawla ma'am. Dr. Priyanka Chawla ma'am is a finance personnel with 11 years of experience in academic domain. Qualifications include MBA Finance and PhD in Management. She has submitted the report of postdoctoral to ICSSR New Delhi. She has attended many conferences, workshops, and faculty development programs. She has published 2 books and has got more than 13 papers published to her credit in reputed journals. Her area of interest includes self-help group, microfinance, operation research, research methodology, and ICT tools. She has been invited as an expert in various organizations and delivered sessions on ICT, RM, and SPSS. Her lectures are also available on YouTube on the subject of entrepreneurship or PM and FM. She has rendered her services to many organizations. Presently, she is associated with Delhi College of Business Management. She has been recognized with various awards. Recently, she won the Best Research Paper Presentation Award in an international conference organized by Prestige Institute of Management and Research, Indore. Thank you so much, everyone. I would like to welcome Priyanka ma'am and to enlighten us, please.
A very good evening to all the dignitaries, delegates, and participants present over here on this virtual platform. And thank you, Divya Agarwal ma'am, for this lovely introduction of mine. And here I would like to thank Rama University and Research Foundation of India for making me a part of this faculty development program and giving me opportunity to deliver session on SPSS. So yesterday we had studied how to punch data into the SPSS, how to export data, and how to import data. Right? So I'm going to share my screen. And what topics we are going to study today is my screen visible?
Yes, ma'am. Yes, it is visible, ma'am.
Thank you. Just a minute. So today we will be covering topic on presentation of data, descriptive statistic and inferential statistic, and normality of data. How to check the normality of data. If we talk about presentation of data, what do you understand by presentation of data? Can anybody tell me? Once we collect data with the help of questionnaire, then we feed or punch data into SPSS. Can we directly apply test? Hello? Can anybody tell me how to present data or what is presentation of data? Can we directly apply test without presentation, without descriptive study. Talking about presentation of data, we present data in two ways, with the help of table and with the help of graphs, right? Is my voice audible?
Yes, ma'am, audible.
Go ahead.
Table means table are used for frequency distribution, and graphs are used on the basis of measurement of scales. And yesterday we had studied about measurement of scales. What type of scales are there? Nominal, ordinal,
Cardinal.
interval, and
Ratio.
ratio. What is nominal data? Nominal scale? If I ask about religion, Hindu, Muslim, Sikh, Isai, what type of scale is this?
Nominal.
Nominal, because we are providing coding only, right? 1, 2, 3, 4. If I ask just to provide preference, which car is best? Honda City or Ferraro or Tata? Which car is best? Then which type of data is this?
Ordinal.
Ordinal. And if I simply ask respondents just to put your age, just to put your age, just to mention your age. If I ask all the respondents, suppose there are 10 respondents, and if I ask 10 respondents just to mention your age, then what type of data will it be? Somebody will say ki I'm 40 years old, somebody will say I'm 50 years old. Which type of data is this?
Scaling.
Scale. That means it is scale data, right? Continuous data. So, talking about presentation of data, there are two ways of presentation of data. First one is with the help of table. Table are used for frequency distribution. Okay? And graphs are used on the basis of measurement of scale. If you measure if you measure a variable on nominal or ordinal scale, if you measure a variable on nominal or ordinal scale, then which graph is to be used, that we will discuss today. If you measure variable on interval scale, then which graph or which type of descriptive study will be used, that we will discuss today, right? So, I'm talking about presentation of data. So, if you measure a scale on nominal and categorical scale, then the best way of presenting a data is frequency distribution, bar chart, pie chart, cross tabulation, and mode. If it is an interval scale, then we can use histogram, scatter plot, mean, median, mode, mean, median, ranges, standard deviation. Okay. Now, one by one, we will check how to describe data and how to plot graphs. So I am opening the SPSS file. So gender is nominal, right? Is also nominal. So for nominal data, which graph is suitable for nominal or ordinal? Which graph is suitable? Pie chart, bar chart, right? So we will learn how to plot graphs. This is the data set. Just click on analyze. Okay. Then go to descriptive statistic. Then can you see this frequency? Just click on this. Transfer this gender. This is a dialog box. that will open up. This dialog box will pop up. Just transfer this. Click on this. Can you see this chart? Click on this. Since this is a nominal data, that means we can use either bar chart or pie chart. Histogram is used for interval scale, right? So first, we will check how to plot bar chart. How do you want to view this bar chart? On the basis of frequency or percentage? Generally, we use percentage. Okay, continue and then click on OK. Achha, one more thing. Can you see this? Percentage analysis.
Yes, ma'am.
Now my question is, achha, okay, first of all, let us check this chart. Then I'll ask one question. How can you analyze this? How can you analyze this? Gender. We cannot see percent over here, right? Just click on this. This window will pop up. And then click on this element, show data labels. See. That means we can say that 74.24% are male and 25.76 minimum percentage of female were there. Okay. If you want, you can change the color. Just double click on this. This window will pop up. Can you see this? Color option, you can change the color as well. Clear? Now, you can just copy or paste into the Word file or you can import. You know how to import data set, right? Now, another thing is age is also nominal scale data, right? That means we can use either bar chart or pie chart. Even marital status is also nominal. Education is also nominal, right? We have given coding. So, if I want to present data in a graphical way of marital status, what can I do? Just go to Analyze, Descriptive Statistic, go to Frequency. Now, just click on Reset. Now, click on Marital Status, transfer this variable into variable column, click on Charts. This time, I want pie chart. I simply clicked on this and percentage. Continue and then OK. Right? Again, I cannot see the data label over here. I simply double click on this, click on element and show data label. Clear? I hope this chart is clear.
Yes, ma'am.
Okay. Now, my question is, what is descriptive statistic?
May I?
Yes.
I have a doubt. Ma'am, as age is also be a part of frequency also, we can also put it in the other chart?
Yes, you can. It depends on you, how to view your data.
Okay.
Okay.
Yes, ma'am.
If you want, you can click on frequency here. Suppose this time I'll take bank account. Let's see the option of bank account. Do you have bank account or not? Yes or no? This is categorical, or we can say binary form in the form of two variable, two attributes. So what I'll do, clicked on analyze and descriptive statistic, frequencies, bank account I'll transfer, clicked on chart, and then again I'll take pie chart, and this time I'll take frequency over here. Okay. Now my question is, what is descriptive statistic?
A brief
Descriptive statistic.
detail about the data.
Yes, descriptive statistic means we are describing data in terms of mean, median, standard deviation. That means in a descriptive statistic, we can calculate central of tendency as well as measure of dispersion. While in inferential statistic, we draw conclusion based on sample. Okay, with the help of hypothesis testing. That means simply in simple word we can say कि in inferential statistic we use test. Based on test we draw conclusion. Right? So if I talk about descriptive statistic, this table shows descriptive statistic, right? There are maximum number of male 74%, then female, right? This is also descriptive statistic. Descriptive statistic means it is showing percentage analysis, it is showing mean, it is showing median, not median, mean, standard deviation, or I can say central tendency or measure of dispersion, right?
Correlation and regression is also part of descriptive.
Yes, but we are talking about this basic part. That's why I am talking about this chart and descriptive analysis.
Okay.
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 Next day, tomorrow or the day after tomorrow, I'll show you which type of hypotheses are there. There is a hypothesis of relation, which is showing relation between the variable. There is hypothesis of differences, which is showing difference between the variables. Which tool is best fitted for which type of variable? So tomorrow or day after tomorrow, we will show you which statistical tool is appropriate for which type of data, right? If there is nominal data, which tool is to be applied? If there is univariate data, which tool is to be best fitted for that? If it is multivariate data, which tool is be fitted for that? Okay. Now, we had learned about charts. If nominal or ordinal measurement of scale is there, that means we will use bar and pie chart. What if interval scale is there? What type of data is this? Can anybody tell me? It is based on strongly agree, disagree, neutral, agree, and strongly disagree. So which type of data is this? Nominal, ordinal, scale?
Ordinal.
Scaling.
Ordinal.
Yes. Some people consider it as a ordinal scale and some people consider it as scaling data. Okay. If you do individual statement, this is individual statement. T1 is individual statement. So that's why we can consider it as ordinal scale. But if I make some changes in that, if I add all these 5 variables, T1, T2, T3, T4, 5, okay? If I add all these variables, or if I find out the average of these variables, then it will be considered as scale data. Okay. So here I found this. I had added all these variables. T1, T2, T3, T4, T5. Okay. So here I can say it is ordinal data. Individual statement is called ordinal data. But when we make any arithmetic performance, then it will become scale data. Clear? Now, this become a scale data. I'll show you how to convert this data.
Priyanka ma'am, a small query before
Yes.
we open it. Ma'am, can you just throw a small example on that?
Yes. I'm opening that data set.
Thank you.
Can you see this marks? This is the marks of students in Tamil subject, in English subject, science subject, math subject, social science subject. ठीक है? Can you see this?
Yes, ma'am.
If I add all these marks, just a minute. Can you see this data? T1, T2, T3, T4, T5. This is an ordinal scale, and it will be better if I show the demo on this. This is individual statement stating ordinal scale data. This is another individual statement stating ordinal scale data. Okay? T1, T2, T3, T4. Now, how to convert this ordinal scale into scale data?
Ma'am, we have to decide that which data is nominal and which is ordinal. Software will not know what is ordinal and what is nominal. We have to decide.
Yes. So, if it is statement, if it is a single statement, this is a single statement related to T1. This shows strongly disagree, this shows disagree, this shows neutral, this shows agree, this shows strongly agree. So simply, if it is one statement, that means it is ordinal data, right?
Okay, ma'am.
Okay. Now, when you add all these T1 to T5, that will become scale data. How
Scale.
to compute this? That I'm going to show you. Just go to compute. This is transform, and just click on compute variable. Okay? This is target variable. Target variable means new variable that will be created. So sum of T1 to T5, right? So new variable. I'm giving the name new variable. What I'll do? Just click on statistic. Here, statistical. Can you see sum over here?
Yes, ma'am.
Function group. I can see statistical. I just simply clicked on statistical, and in the dialog box, which is just given below this function group, I clicked on sum. And then, can you see this arrow? Clicked on this. Now what I have to do? I have to add all these items, T1, T2, T3, T4. So just simply transfer this and then comma. T2, just simply transfer this and then comma. T3, comma. T4, comma, and then last T5, just I'm going to transfer this and then click on OK. Clicking on OK. The new variable will be created. Can you see this? New variable. I have added all these ordinal scale. Okay? And then it becomes scale data. Now I can perform, which is the suitable test for that. Now, data has become scale data. Now, how to present this. Which graph is suitable for this? Since it becomes scale data, which graph is suitable for this? I already explained you. Either it would be histogram, it would be polygon, it would be stem leaf, right? It is not nominal or ordinal data, so we cannot use pie chart and bar chart, right? Now, this is new variable. Now, how to describe this data? Just go to Analyze, click on Descriptive Statistic, click on Frequency. This time, I'll transfer this new variable over here as it has become scale data. Now, which type of chart is appropriate for this type of variable? Not bar chart, not pie chart. Histogram is appropriate. I simply clicked on this and also click on Show Normal Curve on histogram. Then continue and OK. Can you see this?
Yes, it is visible.
So what I did, as it has become scale data, so I use histogram. Histogram means bars and bins are used. Okay? Is this clear?
Yes, ma'am.
No. So that means we have learned how to present data. We present data either in a tabular form or in a graphical form. Okay? If you measure a variable on nominal or categorical scale, then we will use bar chart or pie chart. And if it is interval scale, that means we will use histogram, polygon, or stem leaf. Right? Now, my second question is, I've already asked what is descriptive statistic. So descriptive means we are going to describe data, right? Describe data in the form of central tendency, mean, in the form of measure of dispersion. That means standard deviation, ranges, right? And inferential statistic means we have applied test. We are drawing conclusion on the basis of hypothesis testing. That means in descriptive statistic, we will not apply this test. This is simply a percentage analysis. We are just simply describing the data. So how to describe data? This is a percentage analysis. So I'll give you a demo of this also. This is a scale data tangibility. Go to Analyze, Descriptive Statistic. This time go to Descriptive. If you are going to describe data, then go to Descriptives. This is tangibility. I'm transferring this tangibility over here. Go to option. In option, click by default mean is already marked. Standard deviation is already marked. Minimum, maximum is already marked. Click on Cartosis and Skewness. Okay? And then continue. And then OK. This is the way in which we can describe data. How can you describe the data? Can anybody tell me? How many N are there? How many respondents are there?
66.
66 is the sample size. Minimum stats means minimum range is 11 and maximum range is 25. The difference is
40.
range is not given here. Skewness is minus 0.11 and Cartosis is 0.03. Now I'm going to explain what is normality of data. Then I'm going to explain how to check the normality with the help of Skewness and Cartosis. Okay? So, what is normality of data? We have to check whether the data is normal or not. This is the assumption of parametric test. This is one of the assumption of parametric test. Tomorrow we will do parametric test and day after tomorrow we will be doing non-parametric test. So parametric test क्या बोलता है कि we have to check whether the data is normal or not. So there are various ways to check the normality of data. We cannot simply apply test after punching the data into SPSS. We have to check whether the data is normal or not. Then it is better, first we convert the data into normal, then it is better to apply test. Otherwise, your result will never come. There are various ways to check normality of data. One of the way to check normality of data is through graphical method and another way is statistical technique. In graphical method, we use histogram, QQ plot, and box plot. And another statistical technique, that is numerical form, we use Skewness, Cartosis, and Kolmogorov-Simronov test, AS test. These are the ways to check normality of data. So first we will look graphical method. Clear? First we will check graphical method. Under graphical method we will be taking first histogram. Histogram means it is a graphical representation of data where we are using bins and bars, right? There is no gap between the bins, right? And it is used in interval scale or continuous scale only. We will not use this histogram. We will not check normality in case of ordinal or nominal data. We check normality in case of interval or continuous data only. So first way is with the help of graphical. Under graphical method, we will be using histogram. So this is, there are various kind of histogram. If the data, if the curve is like this, symmetric or bell shape, then it is considered as normal data. If the curve is showing bell shaped symmetry, then it is called normal data. Here mean is equal to median is equal to mode. All are equal. Now, what type of histogram will be there? See, can you see this?
Yes.
Yes. Which one is normal data? There are various type of distributions. Which one is representing the normal data?
Middle one.
Second one, normal distribution.
Here, what is representing? It is representing mean is equal to median is equal to mode, right? It is showing bell-shaped curve.
Bell shape.
Right. If I talk about this first one, either left, can you see this?
Yes.
Left tail curve is greater than right tail. Left tail curve is greater than right tail, right? So we can say it is
Negatively skewed.
to the left towards skewed. It is skewed towards left. It is skewed towards left, right? It is negatively skewed data. Can you see this? This one?
Yes, ma'am.
Right tail curve is greater than left tail. It is showing positive skewed.
Good.
Right? This one, fourth one. This is showing uniform distribution. Here we can see there is no peak. Data is not symmetrical. Here we can see two symmetry. Two modes are there. That means two symmetries will be formed. This is 1 and this is 2. This is called bimodal distribution. And last one, can you see this? This is also bimodal, but it is not symmetry. Here the curve is different and here the curve will be different. Right? So we want, for normal distribution, we want this type of curve. So this is the way of checking normality of data. Again, this is bell shape. This is bimodal. We can see here the right tail is greater. No left tail is there. Only right tail is there. It is called J shape. Here right tail is greater than left. So it is called right skewed data. This is called U shape and this is called uniform. That means there is no curve over here. Right? So I'll be using one example. Let us take the same data set. I'll be using this reliability. I'll check the histogram on reliability variable. So what I'll do, I'll go to analyze. Go to descriptive. Just a minute. I'll go to analyze, go to descriptive, and then frequency. Tangibility or reliability, I'll transfer over here. Can you see this chart? I'll click on histogram and show normal curve on histogram. With the help of this, I can see whether the data is normal or not with the help of histogram, right? Continue. Okay. Can you analyze the data normal?
Yes, ma'am.
Yes.
Right. Now, can we move on to another?
Is it normal? It was skewed to the left hand side now. The graph that we just showed.
No. It is not like that. If it is left or right now, it is highly skewed. We cannot say it is highly. So data is somewhat normal. We can say data is somewhat normal. If it is skewed toward left or toward right, then it would be like this. Can you see this?
Yes, sir.
The scale would be longer. Okay.
Fine.
Now, another way of testing normality of data is QQ plot. What is QQ plot? Any idea about this? Any idea about this? QQ plot? It is also one way of finding out the normality of data. If these data points are closer to the line, can you see this? Data points, small circles are there. If these data points are closer to the line, that means the data is normal. Okay?
Yes.
If data points are going up, this is normal. Okay? It is closer to the line. If data points are going up above the line, can you see this? These data points are going up. Then it is called skewed toward left. If data points are going beyond this line, can you see this? Going beyond this line, it is called skewed to the right. If data points are showing S, that means thick tail is there. That means it is a case of Cartosis. And if it is showing reverse S, it is a case of Cartotic. I'll show you.
Ma'am, please can you repeat if you don't mind?
QQ
From
plot, another way of showing data. If QQ plot is another way of showing normality of data, if these data points are closer to the line, can you see this line?
yes, ma'am.
These data points are attached to this line. It is closer to this line. That means data is normally distributed. If these points are going up, can you see this? These points are going up above these lines. That means it is skewed toward left. Okay, it is not normally distributed, in short. If these data points are going beyond this line, can you see this? It is going below this line. See my mouse arrow.
Go ahead, ma'am. Yes, ma'am.
It is going below this line. That means the data is skewed to the right. And if this data point is showing S, that means it is thick tail. It is a case of lipocartic. And if it is reverse, if it is showing reverse S, that means it is having thin tail, and it is a case of platycartic. Okay, let us have one demo on that. I'm taking the same data set. Go to analyze, descriptive, and QQ plot. Can you see this QQ plot? Just click on this. Transfer this variable, response or reliability, whatever it is, response variable. I will be taking response and reliability. Okay. And just simply click on OK. Now, what is QQ plot saying regarding reliability?
It is normal data.
Yes, not. Data points are closer to the line. What analysis can you make for response variable?
It seems like left tail.
Some data points are going above this line, right? Some
Right
data
side.
points are going right. It is skewed to the right. Right. Yes. Clear?
Yes. Ma'am, can I ask one question?
Yes.
Ma'am, if my whatever I data collected, if it is not normal, then I need to convert
Yes,
it
yes,
into right?
that I'll show you.
Okay, thank you.
Now, another way of showing normality of data is with the help of box plot. What is this? Any idea about this? What is this?
It's a way of
box plot.
showing by the way of 5-point summary.
No. This is the another way of showing
Box
normal
plots.
data with the help of box plot. This is called box plot. Okay.
Okay.
So what we do, this line, can you see this middle line? It should be in the center, always in the center. Okay. If this point is in the center, that means data is normal. Can you see this whisker? Yeah, this is called whisker line. This is called upper whisker, upper extreme or upper whisker. This is called lower extreme or lower whisker. Okay. If data points fall within this upper and lower whisker, if data points fall within this whisker, upper and lower, then the data is considered to be normal. That means there is no outlier. Clear? If data points go beyond this whisker, see, can you see this? Black spot, black circle over here.
Yes, ma'am.
This is called outlier. Okay? So we have to remove these outliers to make the data clean. Let us have one demo on this. I'll be taking the same data set. Assurance. This time I am taking assurance variable. And we are using box plot, right? Go to graph, legacy dialog. Can you see this box plot over here? Click on this. Simple, click on the simple one, and summaries of separate variable. Click on this. Click on define. Transfer the variable over here. We will take tangibility, reliability, response, assurance. And then click on OK. I think it is better if I go one by one. Okay. Can you analyze this? This is the case of tangibility. This is the case of reliability. This is the case of response. This is the case of assurance.
In tangibility, I think there is
One outlier. This is one outlier. Outlier means data points which are not matched with the remaining data points, which is outlier. Suppose you are taking collecting data from the respondents with the age between 18 to 30. Okay? Your limit is up to 18 to 30 years. That means you are collecting data from the respondents whose age is between 18 to 30, right? But if somebody, by mistake, instead of writing 25, he wrote 55, that will become outlier, right? Now, which is showing normal data?
Reliability.
Reliability. There is no outlier, and we can see this middle line. Okay? So these are the various ways of normality of data with the help of graphical way. Now, another way is with the help of statistical technique, right? Some more ways to check the reliability of data, normality of data is with the help of statistical technique, or we can say in numeric form. The first one is skewness or Cartosis. So first we understand what is the skewness and what is Cartosis. Now, skewness means it is a measure of symmetry. Okay? Matlab, same bell-shaped curve will be there. Mean is equal to median is equal to mode. This is called symmetry. If this symmetry is there, that means data. That means it is skewed data. Now, what is the rule of this? Rule is your skewness value should be between -1 to +1. Clear? If you want to check normality of data with the help of skewness, the skewness value should be between -1 to +1. Clear? Now, This is showing right tail curve. Right tail curve is greater than left. Right? That means mean is greater than median is greater than mode. It is positive skewed data. This one is showing left tail curve is greater than right one. This is negative skewed data. That means mean is smaller than median and median is smaller than mode. But we want this type of skewed data, and the value of skewness should be between -1 to +1. Any value within this limit, -1 to +1, will be considered as skewed. Okay? Now, what is Cartosis? Cartosis क्या बता रहा है? Cartosis is a measure of heavy tailed data or light tailed data. मतलब thick tail or thin tail. Can you see this Cartosis? This is normally distributed. Can you see this? Mesocartic. Mesocartic means normal distribution. Leptocartic means this is leptocartic. That means tails are distribution is longer, peak is higher, and tails are flatter. This one, higher one. Peak is higher. Can you see this? Peak is higher. Distribution is longer. Okay. Talking about platycartic. Platycartic means this one, third one. We can see that distribution is shorter and this tail are thinner. Can you see this? Platycartic. Now, what is the rule of thumb? It says that any value fall within -3 to +3 will be considered here for Cartosis. That means for skewness, we have to check whether the data is normal or not. So any value fall within -1 to 1 will be considered, and for Cartosis, any value within -3 to +3 will be considered as valid. Clear? Now, let us have some demo on this. Same data set. Now, how to check the Cartosis and skewness, right? Go to analyze, go to descriptive statistic. Can you see this descriptives? Under descriptive statistic, just click on descriptives. Click on reset. Transfer the scale data. These are scale data, tangible reliability, right? I'll be taking this, any variable over here. Go to option. By default, mean is marked, standard deviation is marked, minimum maximum is marked. Click on range. Click on Cartosis. Click on skewness. Clear? And then continue. Okay. Now we are going to describe data. The sample size is 66. The difference between minimum and maximum is 15. So this is called range. Mean is 18. Standard deviation is 2.9. Now, how to check whether data is normal or not? With the help of skewness, any value fall within -1 to +1 is considered. So, is data skewed or not?
It is not skewed, madam.
This is 0.1. It should be under -1 to +1.
Okay. It's 0.1.
Yes, it is normally distributed. We can say on the basis of skewness. Can we say this? The condition of skewness is fulfilled. Can we say this?
Yes.
Yes.
Talking about Cartosis. Cartosis says any value fall within -3 to +3 will be taken. So this is showing 0.120. So can we say
Yeah, normal.
normal data? Based on Skewness and Cartosis, the data is normally distributed. Clear?
One question, if I can ask.
Yes.
Ma'am, like you said that if the value of skewness is between -1 and +1, then it is skewed. But
Normally
0 is in between.
normally distributed. That means data is normally distributed. Symmetrical.
Yeah, but if it is 0 only, then it is normally distributed.
But
If
we
skewness
consider,
value,
yes, we consider this. Every time you cannot say ki the value of skewness is 0. Right? Na?
but
The
it is
rule of
lying
thumb is
between
saying,
-1 and
the rule of thumb is saying ki it should be between -1 to +1. It can vary between these. So we consider it as normal.
No, that is okay. But my question is that if we are saying that value of skewness is between -1 and +1, then it is skewed.
See, if the skewness is between -0.5 to 0.5, it is fairly symmetrical. If the skewness is -1 to -0.5 or 0.5 to 1, it is positively or moderately skewed. We can say this.
Okay.
But I am taking as per Hare et al. If you have read the book of Hare, what he says, any value which is lying between -1 to +1 in case of skewness will be considered as normal. Data is considered as normal. Okay. The rule of thumb is saying this. Some people says that the value of Cartosis should be -1 to +1, but in some books it is written that it should be between -3 to +3. Okay. So for skewness and Cartosis, experts are saying different things. Some experts are saying different, but rule of thumb is this. There are some more methods of showing normality of data, and I'll show you that one also. Another one is Kolmogorov-Smirnov test, KS test. Right? What is KS test and how can we find out? Any idea about this? This test says that data is normally distributed. We are assuming two types of hypotheses are there. One is null hypothesis, second one is alternative hypothesis. So we are assuming that data is normally distributed. Okay? Or we can say that the sample data is not different from normal population. So what we are doing with the help of hypothesis testing, we find out the p-value. If p is greater than 0.05, we can say that data is normal. The KS test is satisfied. And in KS test, when we apply this KS test, we can apply all the graphical way as well as a statistical technique, which I had explained. Box plot, QQ plot, and histogram, skewness, Cartosis. All these things are applied at one place when we apply this KS test. Okay? Let us see this. I'm taking this example also. This time I'll be taking another data set. Normality check. First, to check the normality, we should know key data is scale data or continuous, right? This is a scale. Can we apply this normality? How can we apply this normality? Either through graphs, either through skewness and Cartosis. But this time I'll be taking help of KS test, Kolmogorov-Simronov test. So how to do this? Just go to analyze, go to descriptive, under descriptive, click on explore. Can you see this explore?
Yes.
Click on this. All these variable are scale. Just transfer this weight over here in the dependent list. Go to statistic. No need to change anything. Click on plots. Under plots, by default, it is mentioned factor level together. No need to change. By default, it is marked stem and leaf. No need to change. Click on histogram and click on normality plot. Okay? Then continue. In options, there is no need to change anything. Okay. Now, we will see all those things which I had explained earlier will come here. How to check normality of data with the help of skewness and Cartosis. So, can we say data is normal with the help of skewness?
Yes, Mani, yes.
Can we say data is normal with the help of Cartosis?
Yes, yes, yes.
Yes.
Can we say with the help of KS test, the significance value, the p value, this is p value. P value should be greater than 5%, 0.05. P value, this is p value, 0.07. P value should be greater than
0.05.
Yes. 5% is we are taking risk. Okay. It is greater than 0.05. That means KS test is also showing positive result. Data is normal.
Yes.
Based on all the statistical technique, data is normal. Now, we will see with the help of graphical method. This is showing histogram. There is no curve over here. How to check normality of data under curve? Just double click on this. Can you see this? Show distribution curve. Just click on this. Can we say data is normal?
Yes, ma'am. It is.
Yes.
What about QQ plot?
It is right tailed.
Are you sure it is right? It is going below this line. Okay. It is right or left? Right.
Yeah,
And
right.
if it is going above this line, then it will be left. Okay. Now, so can we say the data is normal, whether it is right or left?
No.
QQ plot says that the condition is not satisfied based on box plot. What is box plot saying? There are some outliers, right?
Yes.
Okay, we will remove this outliers, but data is normal. We can see this line over here in the middle.
Yes, data is normal.
Only QQ plot is saying the condition is not satisfied. But we will consider, as per statistical technique, we will consider that data is normal. So we will consider the data is normal, right? Whatever condition is fulfilling, we will simply put into our paper. Yes, data is normal due to this KS test or skewness or Cartosis. Right? Clear? Now, what if data is not normal? Taking this, first of all, I'll show you outlier. No? Can you see this? Height, which is given in meters.
Yes.
And how to check outliers? We will check outlier with the help of box plot. Go to analyze. Descriptive, explore. Simply transfer this height meter over here. Go to plots, histogram, normality, continue. No need to change anything from option and statistic. Okay. Go and click on OK. Is the data normal? Skewness value is greater than.
Not
It is,
normal.
no,
Not
not normal,
normal.
because it does not lie between -1 to +1. So even Cartosis value is showing
Higher than 3.
higher value, 19. Test of normality is showing p value is smaller than 0.5. Again, data is not normal. QQ plot is not also showing data is not normal. Can you see box plot over here? And there is one outlier. Can you see this? How to remove this outlier and what it is saying? Coming back towards the data set. These are the heights which are given in meters, right? And it falls within 1.6 to 1.8, right? But we can see this that, oh, there are two outliers, sorry. Not one, there are two outliers. We can see this sample number 6 and sample number 7. There are some problem in this. Sample number 6. Where is sample number 6? This is sample number 6 and this is sample number 7. The height in meter is between 1.6 to 1.8 maximum, right? But these are two outliers. Either to remove these outliers or we can change as per the above number or below number. Or we can take the median. Or we can take mean. Or we can even remove. So simply it is better to remove this. Now check box plot. Analyze. Not. I'll go to graph. Graph, legacy dialog, box plot. Simple. Summaries of separate variable. Define. Simply answer this. Height and box represent and click on OK. What is the situation over here? There are no outliers, right?
Ma'am, your mic is off.
Ma'am,
What
you are
was the last
muted.
sentence that you heard? What was the last sentence that what you heard? Skewness, Cartosis was clear, na? Skewness and Cartosis was clear, na?
जैसे मैं बस वो जो आपने बताया था वो आउटलायर्स वो हमने रिमूव किया था अभी लास्ट सेंटेंस में.
ठीक है. After that, na, the mic was muted, na?
Yes.
Okay.
Yes.
Okay. Now I'll be taking the data set of normality check. This one. Now let us check this one or that one. No, this one. Let us check the normality of data of this variable. How to check the normality of data?
Just analyze,
Analyze.
descriptive,
Yes.
then explore.
Explore.
Just go to reset, and then I'll take this variable. I'll be going transfer this variable over here. Now, no need to change anything from statistic. Simply click on plots, histogram, and normality of data. Normality plots with test. Continue. No need to change anything from option tabs, and click on OK. Now, the output shows that can you analyze?
Yes. Venus is not normal.
Even Cartosis is not normal. Test of normality is okay. 0.05.
More than
Just equal.
Okay. Equal. It is better not to consider this. Histogram. Let us check the curve over here. Not normal?
Yeah, positive.
Yeah, it is
Right.
positively
Skew toward right. QQ plot is also showing some problem. Outliers and even box plot is not showing a positive result. Now, what to do if data is not normal? There are various ways if data is not normal to convert these data into normal, either through log 10 or square root. So I'll be taking log 10. Just go to transform, compute variable, new variable you have to create. So log 10. I'm using log 10. So I'll be naming this variable as log 10. Okay? The new variable with name log 10 will be created. What to do with this? Go to arithmetic. Under arithmetic, can you see this log 10? Either click on this arrow or just double click on this log 10. Okay? Remove this question mark and simply transfer this variable. Okay? Under this bracket, in this bracket, and then click on OK. Another variable with log 10 will be created. Can you see this? New variable.
Yes, ma'am.
Now apply these tests over here. Again, check the normality of data with the help of explore of this new variable. Reset. Transfer this log 10, the new variable which we had created. Transfer this. Go to plots. The same treatment will be given to this new created variable. Let us check the skewness. Skewness value?
Normal.
Cartosis?
Normal.
Normal.
Test of normality, case test.
Case test is also normal.
Histogram. Let us check the curve.
Uniform type.
But still, it is showing. Based on graphs, it is not showing proper normal distribution. Okay. And the QQ plot, only one outlier is there. Box plot, okay, box plot is showing normal. That means we have converted data into just a minute. That means here the data was not earlier normal, right?
Yes.
There was showing some mistakes over there. So after applying this log 10 technique, we have converted the data into normal, right?
Yes.
Now, if you have any query, then you can ask. Otherwise, I'll show you something which I want to explain. One more thing related to another question which I would like to ask, but before I ask, I want you to ask anything if you have any query regarding this.
Ma'am, I have a question.
Just a minute. Yes.
Ma'am, is it necessary to convert the normal data into normal data? Can't we compute the not normal data by using other tests like non-parametric tests?
See, non-parametric test is not considered as valid. Okay, always go for parametric test. Why? Because there are some assumptions of parametric test. One of the parametric test is data should be normal. Okay, the parametric test will be that will be explained by Dr. Samir Dubey sir tomorrow, and he will explain why parametric test is much more important than non-parametric test. One of the assumption of parametric test is to convert the data into normal. So first, if it is possible, convert data into normal data. Okay? If still after applying these log 10 or square root technique, if it is not coming normal data, then go for non-parametric test.
Okay, ma'am.
Okay? Parametric test is much more reliable than non-parametric test.
Okay, ma'am.
And another thing is, parametric test is applied on interval scale. Okay? Non-parametric test is applied on nominal and ordinal scale.
Yes, ma'am. Yes.
Okay?
What is the second method you told? Log 10 and second one method is?
Square root.
Square root. Okay. Thank you.
Now, could we get the PT from where you are teaching PPT? That
Sure. And you can also have this YouTube video, na?
Yes, ma'am.
If you want, you can learn it from there also. But I'll try my best to send the PPT on the group.
Ma'am, if in our questionnaire we have incorporated questions based on legal scale, suppose. So in that case, scale would be completely ordinal.
It depends upon your questionnaire. I don't know what are your questionnaire.
Yeah,
what
suppose Likert scale, suppose strongly disagree, neutral, agree, strongly agree.
So it depends upon the type of test which you are going to apply.
Yeah, so in that case, we need to go for non-parametric only because...
No. If it is Likert scale, then...
Suppose 250 responses I have collected from respondents.
Okay.
So shall I go to make it, like as you said, we can group it and then we can convert it from ordinal to scale 1. So that would be the better step, or simply we should go for non-parametric test.
No, you can consider, some people are there who consider this ordinal scale into interval scale. Some people, some statisticians are there who convert this ordinal scale by applying this arithmetic technique that I had shown you earlier, plus minus average. Okay, convert this ordinal scale and then they convert this ordinal scale into Likert scale and then apply statistical technique like factor analysis or whatever they want to, or correlation or parametric test. Some people consider this statement, single statement, as a Likert scale. They directly apply this into their parametric test, taking these variables. But I don't know what techniques, what tests you are going to apply. It depends upon the objective of your study. If you could tell me the objective of the study, then I could help you. Like if you want to do factor analysis, if you want to go for factor analysis, then you have to apply EFA of these statements. Okay? First, you have to apply EFA. After applying this EFA, the factors are formed, then you can go for regression.
Okay. Yeah, this is basic confusion of which test to be applied
That
on
we
what
will cover. That we will be covering in the coming days.
Okay, okay. Thank you.
Okay. Any questions? So shall I ask one question? Let me check chat box. No questions are there. What do you mean by sort? Sort on the basis of ascending or descending? Sorting is something different, huh? Let me clear this thing. Now, shall I ask one question? If you have no questions.
Yes, ma'am.
Can we convert this scale data into categorical data? Or can we convert this categorical data into scale data? Which is possible? Which one is possible?
Categorical to scale?
Any other answer? I'll ask you one more time. Can we convert, is it possible to convert scale data into categorical one, or is it possible to convert categorical data into scale data? Which one is possible?
Scale into category.
Yes. Scale. From scale data, you can convert the scale data. Matlab interval scale can be converted into categorical data, but not categorical data will not be converted into scale. Clear? Now, how is it possible? Any answer?
By assigning numerical value.
Suppose this is, I'll show another data set. I'm closing all these tabs. Suppose, first you tell me whether it is nominal, ordinal, or scale. In this data set,
the screen is not visible.
Yes, sharing the screen. Is this nominal scale, ordinal scale, or interval scale?
Nominal.
Huh?
Interval.
These are the marks of the students. Okay. No values are assigned. We simply collected from the respondents, from the students. Somebody says, I got 52 marks. Somebody says, I got 84, 87, 42, 76. We just noted down all the responses from the students. Now, what is this?
Scale.
Scale data. This is scale data. Okay. Now, if we want to convert this scale data into category, category means 0 to 30 will be considered as fail. 31 to 45 will be given D grade. 45 to 60 will be given B grade, right? Something like that. So we are converting this data, scale data, into category. We are assigning grades. We are assigning codes to that. Okay? So how is it possible? Just go to transform. Can you see this? Recode into different variable. Don't click on recode into same variable. Otherwise, this data will disappear. Okay? Just click on recode into different variable. Okay? Transfer this final marks over here. Name whatever you want. Suppose these are the grades. Okay? Label grades of the respondents. Just provide name. Now, the new variable with grades will be created. Okay? Change. Can you see? Now this marks will be converted into grades. Can you see this? Now, how is it possible? Click on old and new values. Click on range. The students who got the marks between 0 to 30. So value, how much value we should, what type of grade should be given to them? Fail.
Give it a yeah.
Fail. Right. I clicked on this string variable, okay? Because I am string means text, okay? 31 to 45. What value? D grade. 46 to 58. 59. P. Add. 60 to 75. What value should we assign? B. And then add it. And more than 75 or 76 to 100. A marks. Okay, A grade will be given to them. And then click on continue. And then OK. Okay. The new variable will be created. Can you see this? Grades. We have converted the scale data into nominal data. Clear? Instead of grades, we can assign codes also 1, 2, 3, 4. Okay. Instead of grades, we can assign. See, instead of grades, we can assign 1, 2, 3, 4. Okay. Clear?
Yes, ma'am.
From my side, the
Once
session
again,
is.
give the path, ma'am. Yeah.
Sorry?
To convert this.
Sorry, can you please repeat?
Yeah, just what was the path that we followed?
Acha, path.
Yeah.
How to get this grades, na?
Yeah. How
Go to
can we
transform.
convert these? Yeah.
Go to transform, decode into different variable.
Okay.
Transfer this old variable over here, assign new name, and then click on old and new value. Give ranges, provide ranges between as per your convenience, and provide grades or values, whichever is convenient for you, and then click on continue.
Okay. Thank you so
Yeah.
much.
So from my side, the session is over. And tomorrow, Dr. Samir Dubey sir will be going to explain about parametric test and the assumptions of parametric test and with practical session. Thank you.
Thank you.
Thank you, and thank you so much.